Okay, so welcome back, and now we're going to do an application type problem. So let's say we've got an airliner, and we want to estimate and figure out what the height of this airplane above ground level. And let's say we've got two radars, okay, and it tracks the plane, right? So at this instant, this plane is 15 degrees from this angle of elevation, right? So it has an angle of elevation from this radar, 15 degrees, and the angle of elevation from this radar is 35 degrees at the moment that this plane is here, okay? And so the distance between the two radars is 20 miles. So now we want to find out at that point, right, in the flight, how high is the airplane. So that means we're going to find the altitude. So we need to find h, but we're not going to use right triangles because we can't. Because we don't know this or this or this or this piece right here. So we can't use right triangles. If we knew those, we would use right triangles all day long and be done. Here we're going to have to use the law of sines. Okay? So how would we use the law of sines? Well, we need what? Well, we know this angle and we know this angle, right? And we know the side between them. Okay? Well, let's think about it. There's lots of different things we can do, right? We know, let's do this. Let's make this A, B, C, which would make this A, B, C, right? Okay, so we know this, so we know well, immediately we can get this angle here, right? So this is 15 plus 35, which is 50 degrees, right? And so we know that angle B, right, let's write this over here. So angle B is equal to 130 degrees, right? So now we know that the ratio of angle B, sine B over B, is going to equal what? Well, we've got this side, right? If we can get this side or this side, then we'll have two sides and an interior angle. So we either need to find C or A. Okay? Well, doesn't really matter. Let's find C. So that means we want to do sine C over C. And so now if we plug it in, right, so that means we've got sine of 130 degrees over 20 has to be equal to sine of C, which is 35 degrees over C. And of course I'm going to take the reciprocal of both sides. And so that's going to be, 20 over sine 30 is equal to C over sine 35 degrees. And of course, if I multiply both sides by sine of 35 degrees, I get C is equal to 20 times the sine of 35 degrees divided by, oops, this should be sine of 130, sine of 130 degrees. Now, let's round this to the nearest tenth of a mile, because that's what they want us to do. Now, if I do that, I get, let's see here. I get approximately 14.98. Okay, 14.98. Now they want us to round the altitude to a tenth of a mile, so that's why I'm keeping it out to 2 decimal places for the rest of them. Because again, we want to make sure that we round, we're going to need to know the hundredths place to round to the tenths place, okay? So this is going to be approximately 14.98 miles. Okay, now, guess what? Now we can find h. Because if we know that this is approximately 14.98, just thinking off the top of my head here. Yeah, there's more than one way you could do this, but so if, now with this here, now all we need to do is use h. Okay, now we know, now that we have a right triangle, we know that, hey, we can use the sine of 15 degrees is equal to h over c. Okay, so guess what? That's what we're going to do. So we know sine of 15 degrees, right? Sine of 15 degrees is opposite over hypotenuse, which in this case is c. And so now h is then equal to what? C times the sine of 15 degrees, which is equal to what? 14.98 times sine of 15 degrees. And now this one we're going to round to the nearest tenth of a mile. And so here we get approximately 3.88. And so this would be 3.9, approximately 3.9 miles above the ground. Okay? And so that is the height or altitude of the plane. Have a great day.